Hey guys, tonight we're going to embark on a journey, and I want you to settle in for this one. Maybe take a deep breath, feel the softness of your sheets, and let the calmness of the night surround you. Picture yourself standing outside, maybe on a cool evening with the sky stretched above you like a velvet blanket, dotted with tiny flickers of light. It's a feeling we all know, the kind of peace that only comes when you're looking up at the stars, letting your mind drift. Now, I'm not here to tell you about constellations or ancient myths, not tonight. No, instead, we're going to wander into a question that's been asked by dreamers, philosophers, and scientists for as long as we've looked at that same sky. What's the largest thing in the universe? It's a question that sounds simple at first, right? You might think, well, the answer's easy. The biggest thing must be this enormous, obvious object. But as soon as we start to look closer, we begin to realize that the concept of largest isn't so simple. The universe, after all, doesn't play by the rules of the things we see every day. The larger things in the world around us, mountains, oceans, the towering trees in a forest, those are objects we can understand on a personal level. But how do you even begin to imagine something that stretches across billions of light years, or a star that could fit hundreds of thousands of Earths inside it? So before we try to answer, I want you to think about where you are right now. Maybe you're lying back, feeling the cool air around you. Maybe you've already tucked yourself in, the room dimly lit. You could be at the edge of your bed, your eyes heavy, just about to slip into sleep. Wherever you are, you're on a planet that's part of a vast, unthinkably large universe. When you think about your place in all of this, how does it feel? Do you feel small? Or do you feel like you're part of something so much bigger that it's almost impossible to grasp? And here's the thing. The universe doesn't mind if you're having trouble grasping it. It's patient. It's always there, sprawling out far beyond what we can imagine, waiting for us to keep stretching our understanding of it. So, let's take a step into this vastness together. Now, we need to start with something familiar to us, something we can wrap our heads around. You see, humans have always had a way of measuring size that's deeply connected to the world around us. It's only natural. Size and scale, to us, have always been rooted in what we can experience with our own senses. The tallest mountain, the widest ocean, the longest river, these were the giants of the world for our ancestors, the things that define the scale of existence. Take Mount Everest. Picture standing at its base, looking up at the mountain that rises nearly 9 kilometers above sea level. That's almost 30,000 feet. A number like that feels huge when you hear it, doesn't it? Or think about the Pacific Ocean. More than 160 million square kilometers of water stretching out as far as the eye can see. Even today, with modern ships and planes, crossing the ocean still takes time. These massive features of Earth used to define the very meaning of the word immense. For so long, they were the ultimate examples of size, the largest things we could even imagine. But here's the twist. As big as Mount Everest and the Pacific Ocean feel to us, in the grand scheme of things, they start to look a little, well, small. When you zoom out, things that seemed enormous start to shrink, like stepping back from a picture and realizing that the edges of the frame hold so much more than what you first saw. For example, let's think about the Earth itself. It's about 12,700 kilometers across. Sounds pretty big, right? But when you zoom out just a little, you realize that Everest, the tallest mountain on Earth, is only a tiny bump on the surface of our planet. In fact, it's less than 0.1% of Earth's total diameter. And from space, the view of our planet is entirely different. The oceans, the continents, even the mountains fade into this smooth, blue sphere suspended in the void. The Earth looks so small from up there, doesn't it? And suddenly, the things that once seemed so massive feel like they're nothing more than dots, almost insignificant against the backdrop of the cosmos. But let's take another step back. What happens if we start thinking about the size of objects that orbit Earth, the planets in our solar system? When you think of Earth in comparison to Jupiter, for example, well, Earth becomes almost laughable in size. Jupiter is more than 11 times the diameter of Earth. Imagine that. You could line up more than 11 Earths side by side, and they would barely stretch across Jupiter's surface. Even more mind-blowing is that Jupiter's mass is more than 300 times that of Earth. That's more than 3 times the mass of all the planets in our solar system combined. And that's just one planet. There are others, too, like Saturn, whose rings stretch out so far they dwarf entire continents. And yet, even these massive planets are just little players in a much, much bigger game. Now, let's talk about our sun. If you're thinking of the sun as this big, glowing thing in the sky, that's completely true. On Earth, it's our big, bright star, the one that sustains life here. But when you compare it to the universe beyond, it's not all that special. Sure, the sun is 1.4 million kilometers across, which is more than 100 times the diameter of Earth. You could line up more than 1 million Earths inside the sun. But when you start thinking about the bigger stars out there, some of which are so vast, they would swallow the entire orbit of Earth, of Mars, even of Jupiter, well, the sun doesn't seem all that big anymore. The universe has a way of stretching our minds, pushing the limits of what we think we know about size. You begin to realize that what feels huge here in our little corner of space quickly fades into insignificance when we widen our perspective. And it doesn't stop there. The sun itself is just one average-sized star among billions in the Milky Way galaxy. And when you consider the size of the Milky Way, which contains billions of stars, well, the sun begins to feel like it's hardly even noticeable. But then, the Milky Way is just one galaxy. One. There are billions more galaxies out there, each one containing billions of stars. Some of them are larger than the Milky Way. And even those galaxies, they're only part of even larger cosmic structures called clusters and superclusters, where millions of galaxies come together, bound by gravity. These are the places where size truly starts to take on a whole new meaning. As we move through this journey tonight, one thing I want you to remember is that the largest thing in the universe is not just about the size of an object. It's about where you stand, what you're comparing it to. The larger the scale, the more our sense of size has to shift. And the farther you go, the more humbling it becomes. It's like standing in front of a towering mountain. Up close, it might make you feel small, but from a distance, it's just one of many, one dot in a much larger picture. That's what we're doing tonight, slowly backing away from the things we know and into a space that's so vast, so far-reaching, that even the largest things start to fade into the background. So, stay with me. The more we uncover, the more we'll see just how deep the mystery of size in the universe really goes. We're just getting started. And as we move outward, we'll begin to encounter objects that are so large, so unimaginable, that they almost break the limits of what the human mind can comprehend. But don't worry, there's no rush. The universe, after all, is patient. I want you to keep that image of the Earth and the sun in your mind for a moment. The Earth, so small from a distance, a mere speck in the vast universe, and the sun, this massive glowing orb in the sky. But as we take one step back, we begin to feel the weight of that vastness pressing on us, don't we? It's like staring at the ocean from ashore, the waves rolling in, stretching farther than the eye can see. When you're standing right in front of something, it's hard to wrap your mind around how big it really is. And yet, the more you step back and let your mind wander, the more you realize scale changes depending on where you stand. Now think about this. When we ask, what is the largest thing in the universe? We're not just asking about size, right? We're really asking what we mean by large in the first place. Because size is a funny thing. We all have our ways of measuring it, depending on what we're used to. Most of us measure size with something close to us, our own bodies. Think about it. A foot used to be literally the length of your foot. An inch was the width of your thumb. Yard, arm's length. The things we deal with every day set the scale for everything we see. That's why a mountain, or an ocean, or a whole planet feels enormous to us. It's because we've been trained to think in terms of our own size. But then, what happens when we zoom out? What happens when we look at Earth from above, or even farther than that? Suddenly, those things we thought of as so big become tiny. Think about Everest again. Mount Everest, the tallest mountain on Earth, towering at nearly 9 kilometers above sea level. That's huge to us. But when you compare it to the entire planet, it's just a tiny bump. The Earth is about 12,700 kilometers across, which means Everest, impressive as it is, makes up less than 1/10 of 1% of the Earth's total diameter. If Earth were the size of a billiard ball, Everest wouldn't even make a noticeable bump. It's almost laughable, right? Something so imposing from the ground is nothing more than a scratch on a much larger surface. Now let's take another step out and think about the sun. The sun, of course, seems enormous to us. It's what lights up our days, what warms the Earth, and lets us grow our food and breathe our air. But compared to some of the stars out there, the sun is just an average, middle-of-the-road kind of star. Sure, it's 1.4 million kilometers in diameter, but there are stars out there that make the sun look tiny. There's a star called Betelgeuse, for example, which is over 1,000 times the size of the sun. If Betelgeuse were in the center of our solar system, its surface would extend all the way past the orbit of Mars. Imagine standing on Mars and looking back toward the sun, except the sun isn't the size of a bright circle in the sky anymore. It's a massive, glowing disk that fills up half the sky, much, much bigger than any star you've ever seen before. And Betelgeuse isn't even the largest star out there. There are stars even bigger, like UY Scuti, which is estimated to be nearly 2,000 times the size of the sun. If it were sitting where our sun is, its surface would extend far past the orbit of Jupiter. It's hard to imagine something that big, but that's what I mean when I say size is tricky. Just when you think you've grasped something enormous, something comes along that makes it seem tiny by comparison. And the strangest part? When we look at stars like these, they seem small, almost like dots, twinkling in the night sky. They appear so far away, distant beyond comprehension, that we forget that they're enormous, that they're giants. So, when we ask ourselves, what's the largest thing in the universe? We realize that the answer isn't just about size. It's about perspective. It's about where you're standing when you ask the question. We measure size by what we know, by what we can see. To us, Mount Everest is the largest thing we can imagine, but from space, it looks more like a wrinkle on the Earth's surface. To us, the sun is a huge, unchanging constant, but in the grand scheme of stars, it's actually quite average, a middleweight star in a galaxy full of others. And when you step back even further, when you start to compare stars to galaxies, well, the sun's size begins to shrink into nothingness. I want you to imagine that you're looking at the Milky Way. It's a galaxy, our galaxy, and it contains around 100 billion stars. To put that in perspective, if you were to take every single grain of sand on Earth, every tiny speck you could ever imagine, you still wouldn't come close to the number of stars in the Milky Way. And even though our galaxy might seem enormous to us, it's only one of billions of galaxies in the observable universe. That's right. There are galaxies out there that are hundreds of times bigger than our own, galaxies that stretch across hundreds of millions of light years. These galaxies are so large that they almost make the Milky Way look like a dot in comparison. So when we talk about size in the universe, we're talking about more than just physical measurements. We're talking about scale on a level that's almost impossible for our brains to comprehend. How do you measure something that's 100 million light years away? How do you picture something that stretches across the universe, beyond what we can see or even imagine? You can't. The truth is, the largest things in the universe don't behave the way we expect them to. They don't act like the mountains or oceans we know. The size of things out there, it's not just about height, width, or volume. It's about how far things extend, how much space they occupy, how far their influence reaches. And that's where things get really interesting. When we think about the largest things in the universe, we also have to think about what that means in terms of influence, in terms of gravity, in terms of the way things pull and push on each other. After all, a planet like Jupiter might not seem that large when you compare it to stars, but its mass, its gravity, its influence over the moons that orbit it, well, that's a different story. Jupiter might not be the biggest thing out there in terms of size, but it's a force to be reckoned with. And just like Jupiter, there are objects scattered across the universe whose mass and gravity shape the very fabric of space itself. It's not just about size as we measure here on Earth. It's about how size impacts the world, the galaxy, the universe, and everything in it. And maybe that's the hardest part of this question. It's not just about how large something is, but how it changes the universe around it. The most massive stars, the largest galaxies, the most distant structures, they don't just take up space. They create space. They change the way things move. They pull, they push, they shift everything around them. Their size is not just something we can measure with a tape measure or calculate with a number. Their size is written in the very structure of the universe. I know it's a lot to take in, right? It feels impossible to grasp. But that's what makes this whole thing so beautiful. The universe is so vast, so full of things that we can barely understand, that even the largest things we can find seem to shrink in comparison. And that's what we'll keep doing as we move through this journey. Step by step, inch by inch, slowly expanding our sense of scale, stretching the limits of our understanding. Because the farther we go, the more we'll see that size is not what we think it is. It's bigger, it's deeper, and it's more mysterious than we could ever imagine. Imagine for a moment that you're standing on a hill, looking out across a vast landscape. The valley stretches out before you, and in the distance, towering mountains rise up, their peaks dusted with snow. The view is magnificent, almost overwhelming in its scale. It feels as though the mountains have always been there, immovable and eternal. From where you stand, they seem to define the very meaning of large. Everything feels small compared to them. Your body, your thoughts, the very ground you stand on, seem insignificant when set against the immensity of nature. But if you step back just a little bit, you'll begin to notice something else. Maybe the mountains aren't as unshakable as they seem. Maybe they're part of something larger, something that, on a different scale, makes them look like tiny bumps on the surface of the Earth. You see, the scale of size is a funny thing. The same landscape that felt infinite from the base of the mountain suddenly seems small when you step back far enough to see the bigger picture. What seemed vast now seems almost insignificant. And this, in a way, is how we experience the universe. The human scale, the way we measure size, is rooted in what we can see, feel, and touch. It's built from the world around us, the things we encounter every day. A tree, towering over us as we stand at its base, feels like a giant. The ocean, stretching endlessly in front of us, makes us feel like we're just a speck on its surface. A mountain like Everest, rising so high, makes us feel small like a grain of sand beneath its peak. We measure everything based on our own size, how tall we are, how long it takes us to walk from one place to another, how far we can see. Everything we think of as big is really just big to us. But, of course, the scale we use to measure size isn't universal. It's a product of our human experience. What we feel is enormous is just one small part of a much larger story. To us, Earth feels vast. Standing in the middle of a great city or a wide plain, you get a sense of the land stretching out far beyond what the eye can see. And yet, the Earth itself isn't all that big when you think about it in the grand scheme of things. Earth is about 12,700 kilometers across, which, when you stand on the ground, seems like a huge distance. But in the context of the universe, it's a speck, a tiny speck in a sea of infinity. You might be wondering how something like Earth, so familiar to us, could be considered small. But think about this. Earth's highest mountain, Mount Everest, is just under 9 kilometers tall. It's the tallest thing on the planet. And yet, when you compare it to Earth itself, it's nothing. The Earth is so vast that Everest is barely even a wrinkle in its surface. Imagine shrinking Earth to the size of a billiard ball. You wouldn't be able to feel Everest at all. It would be too small to even register. And that's the first hint at what we mean by large. It's all relative. Our sense of size is shaped by our experience, by the human scale. To us, Everest is monumental. The Pacific Ocean is a vast, uncharted wilderness that feels like it could stretch on forever. But once you zoom out and look at the Earth from space, everything changes. The planet looks smooth, almost featureless. You can see the oceans and continents, of course, but the mountains, the rivers, the forests, they're all tiny compared to the size of the Earth itself. They're almost invisible from that height. From space, Earth is just a blue marble floating in the dark void of space. It's this scale, this shift in perspective, that reveals just how small the things we think of as giant really are. Our brains are wired to think in terms of the world we can experience firsthand. When we stand at the base of a mountain or look out at the ocean, we're experiencing the largest things in our world. But when we step back, when we compare those things to the whole of the Earth, or to the sun, or to the stars, the feeling of enormity starts to fade away. Now, let's take a step further back. The sun is far more massive than Earth. It's over 100 times wider than our planet, and you could fit over 1 million Earths inside it. It's a fact that makes our planet seem very small. But still, even the sun, this source of warmth and life, this enormous glowing sphere in the sky, is just an average star when we compare it to the giants that exist elsewhere in the universe. There are stars out there, stars like Betelgeuse, that are more than 1,000 times the size of the sun. Imagine standing on Earth and looking up at a star so massive it would stretch all the way to the orbit of Mars if it replaced the sun. That's how big Betelgeuse is. And yet, even Betelgeuse is just one of many and not even close to the largest star we know. So, when we talk about size, when we try to understand what largest means, we have to remember that it depends on where we're looking from, what we're comparing it to. When we're standing on Earth, it's easy to think that the planet is the largest thing we know. But when you look at the sun, or Jupiter, or even just the moon, that sense of scale changes. The Earth becomes just one small part of something much larger. And even beyond the planets and stars, there are galaxies. Entire collections of stars, dust, gas, and dark matter, each one a massive structure of its own. The Milky Way, for instance, is home to around 100 billion stars, and yet it's just one galaxy among billions that populate the universe. The size of a galaxy like ours is mind-boggling. It spans 100,000 light years across. A light year is the distance that light travels in a year, about 9.5 trillion kilometers. So, when you think about the size of the Milky Way, you're talking about a structure so vast that even light, traveling at the speed of light, would take 100,000 years to travel across it. It's in these moments, when we step back and look at the universe through the lens of size, that we start to get a sense of how small we really are. Earth, which feels so big to us, is a tiny speck in the vast expanse of the universe. And the universe itself? It's still growing, still expanding. It's almost as if the farther we look, the more we realize how small everything really is. Even the stars we admire so much are just little points of light in the grand scheme of things. And yet, we can't help but marvel at their size. We can't help but stare in wonder at the vastness of the universe. In the end, the human scale is just that, human. It's a product of the world we know, the world we can touch and see. But the universe doesn't care about our sense of scale. It just is. And as we move further into this journey, we'll see that size is not just about how things look. It's about how far they reach, how much space they fill, and how much influence they have. So as we drift further into this cosmic journey, keep that in mind. Size is all about perspective. And the farther we go, the more we realize that there's always something bigger, something that makes us, our planet, our stars, and even our galaxies seem small. Imagine standing on a quiet beach, the waves gently rolling in, and the horizon stretching far into the distance. It feels like the world just goes on forever, doesn't it? The ocean, vast and deep, seems to have no end. But as you sit there, watching the waves come and go, something begins to shift in your mind. What happened if you zoomed out just a little? If you took a step back and looked at the beach from higher up, maybe from a plane or even from space, suddenly that massive stretch of water, the thing that felt endless, would start to seem small. The vastness of the ocean, once so overwhelming, would appear as just a small part of the greater Earth. And from that higher view, you'd see the Earth itself as a small blue marble, spinning in the infinite darkness of space. The shift is subtle but profound. What once seemed like everything now feels just like one part of a much larger whole. This is the kind of shift we go through when we think about size. From our perspective, the world is big. But when we step back, when we start to look at things from a different scale, we begin to see how small our home truly is. The Earth feels immense when you're standing on it, surrounded by nature or watching a sunset. But the more you pull away, the more you start to realize it's just a speck compared to the rest of the universe. Let's start by stepping back just a little bit. Think about the Earth again, but this time, imagine that you're not standing on the ground. Imagine you're in a spaceship, hovering just above the planet. You can see the land masses and the oceans stretched out beneath you, the clouds swirling above. From this vantage point, Earth looks like a beautiful, fragile marble in the vastness of space. It's stunning, isn't it? You might feel a little overwhelmed by how small the planet seems, even though it's the home of every person, every creature, every story we've ever known. But Earth, with all its beauty and diversity, is just one planet in a much larger system, the solar system. Now let's move away from Earth and zoom out to the solar system itself. The planets in our solar system are incredible in their own right, but when you compare them to Earth, you start to see just how varied the sizes can be. The biggest planet we have, Jupiter, is more than 11 times the diameter of Earth. That's a huge difference, right? If Earth were a marble, Jupiter would be the size of a basketball. Imagine that, something so much bigger than what we're used to. Jupiter is not just big in size. It's a gas giant, which means it doesn't have a solid surface like Earth does. Instead, it's made mostly of hydrogen and helium, swirling together in a stormy atmosphere. The gravity on Jupiter is 2.5 times stronger than it is here on Earth, making it a true giant in the sky. And if you think about how many moons Jupiter has, more than 90, it's like a whole miniature solar system on its own. But even though Jupiter is enormous compared to Earth, it's still just a single planet. And when you look at it from the point of view of the whole solar system, you begin to realize that even Jupiter is small in the grand scheme of things. The Sun, after all, is more than 100 times the diameter of Earth. It's so big that more than 1 million Earths could fit inside it. But even the Sun, impressive as it is still just an average star. Our Sun is classified as a G-type main sequence star, which means that there are other stars out there, stars that are both smaller and much, much larger. Some stars, like red supergiants, can be over 1,000 times the size of the Sun. These stars are so big that if they were placed in the center of our solar system, their outer edges would extend all the way past the orbit of Mars, maybe even beyond the asteroid belt. So, what happens when you compare Jupiter to the Sun? Well, Jupiter seems a lot smaller, doesn't it? Even though it's the largest planet in our solar system, it's still tiny compared to the Sun. And it's not just the Sun we need to consider. There are other stars out there, much bigger than our own. Some of these stars are so massive that they make Jupiter seem like a speck of dust. The idea of something so huge, so vast, that it could engulf an entire planet is hard to grasp, but it's out there. It's one of those things that makes the scale of the universe feel almost impossible to understand. At this point, we're starting to see the shift, aren't we? We've gone from thinking about Earth, which feels so big to us, to planets like Jupiter, which are far bigger, and then to the Sun, which dwarfs them both. The more we step back, the more we realize that the Earth, our home, our tiny blue marble in the vastness of space, is small. In fact, it's almost nothing when compared to the stars and the galaxies that surround it. The perspective changes completely. The things we once thought of as giant start to shrink, and we're just getting started. You see, The real fun begins when you start looking at the stars in our solar system. The sun is just one star, and as we've seen, it's already vast compared to the planets. But it's only an average star. It sits right in the middle of the scale between the smaller red dwarfs and the much larger red supergiants. Some of these supergiants are so enormous that they would stretch across our entire solar system, far beyond the orbit of Neptune, and maybe even beyond. Imagine the sun being replaced by a star so large that its outer edge touches the orbit of Pluto. It's mind-boggling, isn't it? But as much as we've explored here in the solar system, there's still more to uncover. Let's zoom out a bit more. What happens when we start looking at the stars beyond our solar system? Our sun, even though it seems massive to us, is just one star among billions in the Milky Way galaxy. The Milky Way is a spiral galaxy, home to around 100 billion stars, maybe more. And yet, even with all those stars, our sun is just a single dot in this vast sea of light. When you start comparing stars, galaxies, and solar systems, you begin to see just how small Earth, and even our sun, really are. And the Milky Way? It's just one galaxy. There are billions of galaxies in the universe, each one full of billions of stars. When you look at these galaxies from a distance, they seem like collections of light. But when you zoom in, when you begin to see the individual stars, planets, and nebulae, you start to realize that galaxies are vast beyond imagination. And even though the Milky Way is one of the largest galaxies in the local group, there are galaxies out there that are even bigger, some that are millions of light years across. It's almost impossible to wrap your mind around how large something like that is. The more we learn, the more we see that size, at least in the universe, isn't really about what's big to us. It's about context. It's about what we're comparing things to. Earth, which feels so immense to us, is really just one small speck in the universe. And when you look at Jupiter, it seems small next to the sun. The sun itself is dwarfed by the largest stars, and even galaxies seem tiny when compared to the cosmic web of superclusters stretching across the universe. But as big as the universe is, as vast as it may seem, it's all relative. What feels gigantic in our everyday lives can be utterly insignificant on a cosmic scale. And that's the beauty of it, isn't it? The universe doesn't need to make sense to us. It doesn't have to fit neatly into the framework of what we understand. It just is. It's there, whether we're able to grasp it or not. It's vast, it's infinite, and it's constantly expanding. But here's the thing. Even though we're just a tiny part of something so much larger, that doesn't make us any less important. After all, this is the place where life as we know exists. It's a home, a planet that we've come to love and cherish. And no matter how small we might seem, in the grand scale of things, we are part of something incredibly special. Picture yourself outside on a warm, sunlit day. The warmth of the sun on your skin, the soft hum of the world around you. It feels comfortable, familiar. It's hard to imagine that something as simple as sunlight is actually coming from a vast, powerful force that could easily swallow up our whole planet. The sun, that constant, glowing sphere in the sky, is more than just a source of warmth. It's a colossal star, a ball of fiery gas that gives us life, that keeps the Earth alive, spinning in its orbit and nourishing everything that grows here. It's so much a part of our lives that we forget to think about how big it really is, how truly massive it is compared to the tiny speck of a world we call home. We see it in the sky every day, sometimes blazing brightly, sometimes gently tucked behind clouds, but always there, without fail, offering us its warmth and light. It's almost easy to think of it as the biggest thing, isn't it? The way it dominates the sky, the way it pulls everything in our solar system around it, the way it makes life possible. In our experience, the sun feels like everything. But here's where things get interesting. The sun, while huge by our standards, is actually just an average-sized star in the grand scheme of the universe. It's what we call a G-type main sequence star. That means it's right in the middle of the pack, not particularly small, but not particularly large either. Let that sink in for a second. The sun, the very thing that sustains life on Earth, the thing that makes the daylight we rely on, is pretty much average. That might be surprising, right? Because in our world, it's everything. It shapes our day, our seasons, our weather. It gives us warmth and light. It's essential to everything we know. But the sun itself, when you compare it to the stars that exist out there, is far from exceptional. It's big, of course, massive by our standards, but when you start looking at other stars, you realize that there are some that are so enormous that they make the sun seem small in comparison. Take a star like Betelgeuse, for example. It's a red supergiant, a star so large that if it were placed in the center of our solar system, it would stretch beyond the orbit of Mars. Imagine that. The sun, which is 1.4 million kilometers in diameter, is just a speck compared to Betelgeuse. It's hard to imagine something so massive. If you place the sun in the center of the solar system, it would fit easily inside Betelgeuse, and that would just be the beginning. The sheer size of stars like this can be mind-boggling. Betelgeuse, as big as it is just one of the larger stars out there. There are other hypergiants like Scuti, which is about 2,000 times the size of our sun. If that star replaced the sun, its surface would extend all the way past Jupiter. Jupiter, the largest planet in our solar system. And yet, that's still only one of the countless other stars that exist in the universe, each with its own incredible size and characteristics. But here's the thing that makes the sun so important to us. It's not just about size. It's not about being the biggest, the brightest, or the most powerful. The sun is our star, and it's the one that makes life on Earth possible. Its size doesn't just matter because it's big. It matters because it's the right size. If the sun were any larger, it would burn through its fuel much more quickly, and its lifespan would be shorter, only a few million years instead of billions. If it were smaller, it wouldn't have enough heat to sustain life on Earth. It's not about being the biggest or the brightest. It's about being perfectly suited for us, for life as we know it. And think about the energy the sun gives us. Every second, the sun emits more energy than humanity has used in its entire history. It's almost impossible to comprehend, isn't it? Every second, this huge nuclear furnace is converting millions of tons of hydrogen into helium, releasing unimaginable amounts of energy that travel across space, bringing light and warmth to our world. That light you feel on your face, that warmth that bathes you in the afternoon, it started as energy deep within the sun's core. It's traveled millions of kilometers through space to reach us, taking just a little over 8 minutes to cover that vast distance. In the grand scheme of the universe, that's an incredibly short journey. But for us, it's everything. Without the sun, there would be no life. There would be no warmth, no light, no seasons, no plants, no animals, no humans. The sun is the source of it all. Yet, even as essential as it is, we still don't fully understand it. Scientists know that the sun is made of hydrogen and helium, and that it's powered by nuclear fusion, where hydrogen atoms are fused together to form helium, releasing energy in the process. That process has been going on for over 4.5 billion years, and it will continue for another 5 billion years before the sun begins to run out of fuel and eventually expands into a red giant. When that happens, it will engulf the inner planets, including Earth, and then, after it sheds its outer layers, it will shrink down into a white dwarf, a dense, tiny remnant of what once was a massive star. But that's billions of years away. For now, the sun continues to shine, steady and constant, providing everything we need to survive. And despite all that power, the sun isn't just a massive ball of heat and light. It's also a dynamic, active force in space. The sun's surface is constantly changing, with sunspots appearing and disappearing, solar flares erupting, and coronal mass ejections sending powerful bursts of solar wind into the solar system. These eruptions are so powerful that they can interfere with satellites and even disrupt communication systems here on Earth. But at the same time, they also create the beautiful auroras in the polar skies. The sun isn't just a passive, stable object in the sky. It's a dynamic, constantly changing entity that has a profound impact on our world. But even with all its power, the sun is still just one star among billions in our galaxy. And when you look at the universe as a whole, it's a tiny part of an even larger picture. The Milky Way, the galaxy that our sun calls home, contains over 100 billion stars. And even the Milky Way is just one of countless galaxies scattered across the universe, each one containing billions or even trillions of stars. It's staggering, isn't it? Our sun is one of the most important things in our lives, but it's just a small part of something so much bigger. The universe doesn't need to center around our sun to exist. It just goes on, with or without us, with or without the sun. And yet, it's hard to imagine life without it. The sun, in all its ordinary brilliance, has shaped everything we know. It dictates our days, our seasons, our rhythms of life. And even though it's far from the biggest star in the universe, it's the one we rely on, the one that sustains us. The sun is the source of everything. It's the anchor of our solar system, the giver of life, the thing we measure our time by. And when you stop and think about it, that's pretty extraordinary, isn't it? The fact that something as simple as sunlight can sustain life on a planet as small as Earth, in a universe that stretches endlessly around us, is nothing short of miraculous. It's a reminder that even in the vastness of space, something so ordinary can be the most extraordinary thing we know. Imagine yourself looking up at the sky on a clear night. The stars are twinkling, and if you're lucky, you might spot a planet, maybe a distant dot of light that stands out from the stars, hinting at the immensity that lies beyond what we can truly grasp. But what if you were to shift your focus? Instead of looking up at the heavens, imagine zooming out far beyond the stars and into the very space we call home, our solar system. It's easy to think of our solar system as something familiar and small, isn't it? After all, we're here, living on Earth, spinning around the sun. We don't usually give much thought to the vast distances between the planets, the sheer scale of the system, and the giants that occupy it. But when you take a moment to really look, when you step outside of your everyday perspective, you realize that the solar system is anything but small. In fact, it's full of giants. Start with Earth. It's our home, the one place in the universe where we know life exists. When we stand on Earth, it feels large, doesn't it? Everything from the oceans, which seem to stretch to the horizon, to the tallest mountains that rise from the ground, it all gives you the sense that you're living on something enormous. But here's the thing. In the grand scheme of our solar system, Earth is just a tiny speck. Sure, compared to the day-to-day objects we encounter, Earth is huge. But compared to the other planets, Earth is modest, almost small. We're not the biggest planet in our neighborhood, nor the most massive. Take Jupiter, for example. If Earth were a marble, Jupiter would be more like a basketball. It's more than 11 times wider than Earth, and you could fit over 1,300 Earths inside it if you wanted to. Imagine that. 1,300 Earths all stacked together inside a single planet. Jupiter is a gas giant, meaning it doesn't have a solid surface like Earth. It's made up mostly of hydrogen and helium, swirling together in thick clouds and enormous storms. And those storms? Some of them have been raging for centuries. The most famous storm on Jupiter is the Great Red Spot, a massive storm system that's been observed for at least 350 years, and it could fit 3 Earths inside it. A storm so big that it could swallow our planet. It's almost unbelievable to think about something like that, isn't it? But that's Jupiter for you, unimaginably massive. Then there's Saturn. Saturn is another gas giant, and while it's smaller than Jupiter, it's still enormous. What makes Saturn particularly special, though, are its rings. When you look at Saturn through a telescope, its rings are one of the most iconic sights in the entire universe. These rings aren't solid. They're made up of billions of particles, from tiny dust grains to enormous chunks of ice, all orbiting the planet at incredibly high speeds. Saturn's rings stretch out hundreds of thousands of kilometers, yet they're only a few kilometers thick. But even with that thinness, the rings give Saturn an appearance of elegance and grandeur. If Earth is a marble, Saturn with its rings would be a beautiful, delicate ball floating in the sky, almost too perfect to be real. As we move outward, the solar system continues to reveal more and more giants. The next planet, Uranus, may be further from the Sun, but it's still a behemoth in its own right. Uranus is often called an ice giant because of its icy composition, but it's not any less massive. The size of Uranus is enough to make Earth seem even more insignificant. The planet's atmosphere is made up of hydrogen, helium, and methane, giving it a pale, blue-green color. Uranus is tilted so dramatically on its axis that it essentially rolls around the Sun on its side, creating a unique and strange dynamic in its orbit. Its moons, too, are numerous and varied, adding to the sheer complexity of this distant giant. And then there's Neptune, the farthest planet from the Sun. Neptune is another ice giant, much like Uranus, but it's a little different. Neptune has the strongest winds of any planet in the solar system, with gusts that can reach speeds of over 2,000 kilometers per hour. Can you imagine that? Winds so fast that they could tear through anything in their path. Neptune is also a world of mystery, with strange dark storms that come and go, like the Great Dark Spot, a massive storm similar to Jupiter's red spot. Neptune, like its twin Uranus, is a giant world with a unique atmosphere, and just like the others, it dwarfs Earth in size and power. When you take all of this in, the gas giants, the icy giants, the moons, and the Sun, you begin to realize that the solar system, in all its beauty, is far from small. Each planet has its own unique characteristics, and though we often think of Earth as the biggest thing in the neighborhood, it's actually just one of many fascinating and enormous worlds that orbit the Sun. From the gentle rings of Saturn to the stormy clouds of Jupiter, each planet in the solar system is a reminder that the universe doesn't just give us small things. It gives us giants, worlds so big, so powerful, that Earth, with all its vast oceans and sprawling continents, is almost a shadow of what lies beyond it. Yet in all its enormity, the solar system is only a tiny fraction of the universe. The distance between the planets, while unfathomable to us, is just a small step when you zoom out and look at the greater picture. Our Sun, at the center of the solar system, is just one star among billions in the Milky Way galaxy. And the Milky Way itself is just one of billions of galaxies in the vast expanse of space. And even though the solar system feels like everything to us, even though Earth is home to all we know, we're just a tiny piece of a cosmic puzzle that's far, far bigger than we can fully understand. As you drift off to sleep tonight, you might find yourself feeling a little smaller, but not in a way that's sad or lonely. No, there's a kind of comfort in realizing just how vast the universe is. It's a reminder that even though we're just one little part of it all, we're part of something much greater. The giants of our solar system, the gas giants and ice giants, the massive storms, the distant stars, everything in this universe is connected, and we're all part of it. And that in itself is a pretty extraordinary thought. So, as you rest here tonight, remember the gentle giants of the solar system. Think about how Earth, with its oceans and mountains, fits into a much bigger picture. Know that as you sleep, you're resting under a sky filled with stars, all part of a galaxy that's full of mysteries, just waiting to be discovered. And no matter how small we feel in the grand scheme of things, we're all part of the wonder of it all. The universe is vast, and we're right here, quietly spinning through it. Have you ever stood outside at night, maybe in the middle of a quiet field or at the edge of a forest, and just looked up? The stars seem so close, almost like you could reach out and touch them. They're like little sparks scattered across the dark velvet sky, tiny yet bright enough to pierce the stillness. It's easy to imagine that these stars are just there, suspended in space, far away but within our reach of sight. But what if I told you that these stars, beautiful and twinkling as they are far more complex, far more powerful than we can possibly imagine? Take a moment to think about this. Stars like the one we see every day, our sun, are not simply glowing points in the sky. They are immense balls of gas, burning at incredible temperatures, generating energy in the form of light and heat. The process that happens inside a star, the fusion of hydrogen atoms into helium, releases energy enough to light up the entire universe for billions of years. And that's just a single star. When you start to think about it, stars aren't just background decorations in the night sky. They're the very engines that fuel the cosmos. They shape everything around them, and without them, life as we know it would simply not exist. Our sun is an average-sized star, right in the middle of the spectrum. It's not too big, not too small, and for us it's perfect. It's been shining for about 4.5 billion years, and will continue to do so for another 5 billion or so before it enters its final stages of life. But even our sun, as important as it is to us, is a small player when compared to the other stars that exist out there. The universe is full of stars, and they come in all sizes, shapes, and temperatures. Some are so small, they can barely sustain fusion, while others are so big, they dwarf our sun by a factor that's hard to even comprehend. Let's talk about the smaller stars first, the ones that are closer to what we might think of as average. These stars, like the red dwarfs, are much smaller than our sun and much dimmer. Red dwarfs are the most common type of star in the Milky Way. In fact, they make up about 70 to 80% of the stars in our galaxy. But here's the thing. Despite their abundance, red dwarfs are hard to see. They burn so dimly that they're practically invisible to the naked eye. And because they're so small, they have a much longer lifespan than stars like the sun. They can burn for trillions of years, far longer than we'll ever be able to observe them. These little stars, though small and faint, have been silently working in the background of the universe for eons. Even though we can't see them, they are an essential part of the starry landscape. On the other end of the spectrum, we have the massive stars. These are the real giants of the universe, stars that burn hot and bright, using up their fuel so quickly that they live short, dramatic lives. The largest stars in the universe are known as hypergiants. These stars are often thousands of times larger than the sun, with masses that can be hundreds of times greater. The sheer size of these stars is enough to boggle the mind. Take a star like VY Canis Majoris, a red hypergiant. This star is over 1,400 times the size of our sun. If VY Canis Majoris replaced our sun, its outer edge would stretch beyond the orbit of Saturn. The thought of something that big, something that could swallow up an entire planet, is almost too much to wrap your mind around. And it doesn't stop there. There are stars out there even larger than VY Canis Majoris. These stars are so massive that their gravity is powerful enough to warp space itself, pulling everything around them into their gravitational embrace. When a star like this reaches the end of its life, it doesn't just fizzle out quietly. Oh no, a star that massive goes out in a blaze of glory. When it runs out of fuel, it explodes in a cataclysmic event known as a supernova. These explosions are some of the most powerful events in the universe, releasing as much energy as the sun will emit over its entire lifespan, all in a matter of seconds. The shockwaves from a supernova can travel across vast distances, triggering the creation of new stars and the formation of new elements that will eventually become part of planets and life itself. And yet, even these massive stars are just one part of the story. The most mind-bending part of it all is that these stars aren't just burning away their fuel. They're doing something far more complex. They're creating heavier elements. Through the process of nuclear fusion, they take lighter elements like hydrogen and fuse them into heavier ones like helium, carbon, and oxygen. As the star continues to burn, it creates even heavier elements, up to iron. When the star explodes in a supernova, it scatters these elements across space, enriching the interstellar medium. The very atoms that make up our bodies, our planet, and everything around us were once forged in the hearts of these enormous stars. In a way, we are made of stardust. It's a humbling thought, isn't it? That everything we know, Everything we are is connected to these stars, to the incredible forces they unleash in their final moments. And here's the part that really hits home. The power of these stars, their light and their energy, is what makes life possible. Without stars like the sun, there would be no warmth, no light, no food, no plants, no animals, no us. Everything that sustains us, everything we take for granted on this planet, has come from stars. Their light gives us day and night. Their energy fuels our climate. Their explosions seed the universe with the elements that allow for life to exist. It's not just the light that shines down on us. It's the way the stars shape everything around us. They are the architects of the universe, the forces that drive the creation of planets, galaxies, and life itself. So, as you lie back and listen to the quiet of the night, think about the stars. Those twinkling points of light are not just beautiful. They are powerhouses of creation. They burn with incredible intensity, creating elements, forging the building blocks of life. And the vastness of the universe, the beauty of the cosmos, is not just about how large everything is, but about the way these stars work together, creating and destroying, shaping and reshaping the very fabric of the universe. The stars are not just out there in the sky. They're the heartbeat of the cosmos, the forces that keep everything moving, that keep everything growing. And as you drift off, perhaps you can feel a little more connected to them. To know that we, here on Earth, are part of a much bigger story, a story written in the light of distant stars. In the vastness of the universe, we may seem small, but we are made of the very same stuff that powers these stars. And in that sense, we're not so different after all. We're all just stardust spinning through the cosmos, sharing the light of a star, the warmth of a star, and the history of the stars that came before us. Imagine standing outside in the evening, maybe on a warm summer night, looking up at the stars. They twinkle softly, scattered across the sky like diamonds against a velvet backdrop. As you stare at the vastness above, it's easy to think that all stars are kind of the same, just distant points of light. But when you stop to think about it, stars come in all shapes and sizes, each with its own story. Some are tiny, faint things, while others are giants. Their brilliance so overpowering that they make the stars around them look almost insignificant. These giant stars, especially the red supergiants, are the ones that really stretch the imagination. Take a star like Betelgeuse. It's one of the most famous red supergiants in our night sky, and for good reason. This star is so massive that if it replaced our sun, its outer edges would reach beyond the orbit of Mars. Imagine standing on Earth, looking up at a star so large that its glow would fill the entire sky. You could walk along the surface of this star for thousands of years and still not reach the edge. It's hard to wrap your mind around something like that. A star that enormous, so massive that it could swallow up our entire solar system, seems almost unreal, like something out of a science fiction novel. But Betelgeuse is just one example. There are other red supergiants out there, some even larger, each one bigger and brighter than the sun, burning through their fuel at a blistering pace. These stars, unlike our sun, burn much hotter and faster. Their enormous size means that they burn through their nuclear fuel much more quickly than smaller stars. While the sun, for example, has been shining for about 4.5 billion years and will continue for another 5 billion years, a red supergiant like Betelgeuse has a lifespan of just a few million years. A star like that burns through its hydrogen and helium at a rate so fast that it doesn't last long enough for us to fully appreciate its magnificence. But when these stars do burn out, they go out in a blaze of glory. Imagine for a moment that you're standing on Earth again, watching as one of these massive stars reaches the end of its life. A star like Betelgeuse, having exhausted its nuclear fuel, would begin to collapse under its own gravity. And as it collapses, it would explode in a spectacular event called a supernova. This explosion is so powerful that it can briefly outshine an entire galaxy. In fact, for a short time, A single supernova can release more energy than the sun will emit in its entire lifetime. The force of the explosion is so great that it sends shock waves across the universe, creating new elements and sending them into space, enriching the surrounding regions with the building blocks for new stars, planets, and even life itself. The impact of a supernova is not just dramatic. It's essential to the cycle of creation in the universe. Without these violent explosions, we wouldn't have many of the elements that make up our planet or even our bodies. It's astonishing, isn't it? These stars, which shine so brightly in the sky, are not eternal. They burn through their fuel, and when they do, they leave behind a legacy, elements that will go on to form the next generation of stars and planets. Our own solar system is made of elements that were once forged in the heart of a star, many of them coming from supernovae that occurred long before our sun was born. The fact that we are literally made of stardust, the remnants of these ancient dying stars, is something that always gives me a sense of wonder. We're all part of that great cosmic cycle, created by these massive stars, destined to return to the universe in ways we might never fully understand. And even after these stars explode, their story doesn't end. The remnants of a red supergiant can leave behind a neutron star, or if the star was massive enough, it can collapse into a black hole. A neutron star is a bizarre object, so dense that a single teaspoon of its material would weigh as much as an entire mountain. And a black hole? Well, that's where the laws of physics, as we understand them, start to break down. A black hole is a point in space where gravity is so intense that nothing, no matter, no light, can escape it. The remnants of a supernova that becomes a black hole are not just an incredible sight in space. They represent the ultimate transformation of matter into something beyond our comprehension. The power of these red supergiants doesn't just change the stars themselves. It leaves behind objects that defy the very nature of space and time. But as awe-inspiring as these supergiants are, they're just a small part of the greater cosmic picture. The universe is full of stars in all stages of life, from newborn stars that are just beginning to form in the heart of vast nebulae, to ancient stars that have burned out and are slowly fading away. Each star has a role to play. Each one contributes to the endless cycle of birth, life, and death in the cosmos. And yet, these red supergiants, these immense, fiery giants, are among the most magnificent objects in the universe. Their size and power are unparalleled. Their energy and life cycle a reminder of the unstoppable forces that shape the universe. Imagine, as you're lying there, falling deeper into sleep, that you are floating out in space, far from Earth, looking back at our solar system. You can see the faint, distant glow of the sun, but it's no longer the most significant thing in your view. There, shining far brighter, is a red supergiant, its light reaching across vast stretches of space. The planet you once called home seems small, insignificant, even in comparison to a star as grand as this one. Yet, even as you float in the silence of space, you know that you are made from the same things, that the atoms inside you were forged in the heat of stars like these millions of years ago. And that's the beauty of it all, isn't it? The universe is vast, and we're just one small part of it, but we're connected to everything. We're all made of the same stuff, the same elements that came from stars like the ones that burned hot and bright long before us. These stars, these red supergiants, may seem so far away, their explosions so ancient, but their legacy is carried with us in everything we touch, everything we see, and in the very atoms that make up our bodies. So, as you rest tonight, as you drift off into the warmth and comfort of sleep, know that the stars are not just faraway lights in the sky. They are part of you, part of everything around you. Their power, their beauty, and their energy are woven into the fabric of the universe. And you, just like them, are made of the same stardust. The next time you look up at the night sky, remember that you're looking at more than just distant stars. You're looking at the remnants of giants, the very forces that made everything we know possible. The night sky above you is vast and endless, the stars scattered like little pinpricks of light across an inky ocean. It's easy to imagine that each star is alone out there, distant and isolated in the universe. But when you begin to look closer, you start to realize something remarkable. Stars don't just sit alone, twinkling on their own in space. They interact with each other, they move together, and sometimes they even live together in families, in systems that can stretch out across unimaginable distances. Stars are not just solitary objects. They are part of much larger cosmic neighborhoods, each one orbiting its companions in a delicate dance that can stretch across millions of years. Imagine, for a moment, standing on the edge of a vast star system, looking out into the space around you. There's not just one star, but a few, and they're all moving in sync, their orbits intertwining. You can almost feel the gravitational pull between them, the invisible force that keeps them in orbit, that binds them together in a cosmic waltz. This is the beauty of star systems, groups of stars that share space and time, influencing each other in ways that we're just beginning to understand. Many stars exist not alone, but in pairs or even larger groups, held together by their mutual gravity. These systems are called binary or multiple star systems. Binary systems, as the name suggests, are made up of two stars that orbit a common center of mass. These stars are often locked in a kind of cosmic embrace, circling each other around a common point. In fact, most stars in our universe are part of binary or multiple star systems, even though we might only be able to see them as single points of light. The two stars in a binary system can be very different from each other, one small and dim, the other massive and bright, yet they are bound together by gravity, moving in harmony as they share their space. One of the most famous examples of a binary star system is Alpha Centauri, the closest star system to our own Sunday. This system is made up of three stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Alpha Centauri A and B are two stars that orbit each other, while Proxima Centauri, a red dwarf, is a third star that orbits the pair from a much greater distance. Though Proxima Centauri is much farther away from the other two, it's still considered part of the same star system. It's incredible to think that in our cosmic neighborhood, there's a system of stars that are so close to us, yet we don't really see them with our naked eye. It's as if they've been living side by side, orbiting together in a quiet, invisible dance for billions of years, and we've only just started to understand their existence. These binary and multiple star systems are not just interesting because of the stars themselves. They also play a crucial role in how stars evolve, live, and die. In a system with two stars, the stars interact with each other in a way that could dramatically influence their life cycle. For example, when two stars are close enough to each other, their gravity can cause them to exchange mass, transferring material from one star to the other. This exchange can make one star grow brighter or more massive, while the other might shrink. In some cases, the interaction between stars can even cause one to explode as a supernova, creating a shock wave that sends massive amounts of energy and material into space. These explosions can trigger the formation of new stars, or even influence the development of planets, shaping the future of the entire star system. And as if that weren't fascinating enough, some of these star systems are even more complex, with multiple stars orbiting each other in a much larger system. These systems can have 5, 6, or even more stars, all interacting with each other in a way that creates a delicate, beautiful balance of gravity and motion. These multiple star systems are rarer than binary systems, but they're still found throughout the universe. In these systems, the stars could be arranged in many different ways. Some might all orbit each other in a kind of chaotic swirl, while others might have a more organized, predictable pattern. No matter the arrangement, though, the gravitational dance between the stars creates an incredibly complex system that is constantly shifting and evolving. If you could somehow stand in the center of one of these star systems, watching the stars move and interact, it would be a breathtaking sight. Imagine looking up at the sky and seeing not just one star, but a whole collection of them, each one a blazing orb of light, moving together in perfect harmony. The beauty of it would be hard to describe, and yet it's happening all around us, all the time, in systems we can't see with the naked eye. Even our own sun is part of this cosmic web, part of a galaxy that's home to billions of stars, all of which interact in ways that shape the entire universe. And just like these stars and systems, our sun is not alone in the universe. It's part of a galaxy, the Milky Way, that contains billions of stars. Our sun, as important as it is to us, is only one of the countless stars that populate this vast galaxy. And when you start to think about how many stars are out there, how many systems are out there, it starts to become almost impossible to imagine. The Milky Way itself is just one of billions of galaxies, each one home to its own stars, its own systems, each one with its own story to tell. And this vast network of stars and systems stretches out across the universe, connecting everything in ways we can barely begin to understand. When you look up at the sky tonight, remember that the stars aren't just tiny, distant dots. They are part of something much bigger, part of a vast, interconnected web of energy and matter, each one interacting with the other in ways that are beautiful and complex. And maybe, just maybe, as you drift off to sleep, you can imagine yourself among the stars, floating in the center of one of these systems, watching the dance of the stars as they move and sync, their light filling the sky. And in that moment, you're not alone. You're part of something far greater than yourself, part of a cosmic system that's been unfolding for billions of years, each star playing its part in the beautiful, ever-changing dance of the universe. Imagine, for a moment, that you are floating through space. Everything is calm and still. Around you, the darkness is broken only by the faint glow of distant stars, their light stretching across vast distances. But there's something different in the distance, something more beautiful than anything you've ever seen. It's a cloud of color, glowing faintly, a delicate swirl of gas and dust. This, you realize, is a nebula, a cosmic nursery, a place where stars are born. But it's also a graveyard, a place where stars go to die, leaving behind the very elements that will give birth to new life. Nebulae are the cosmic recycling centers of the universe, the places where the cycle of life and death plays out on an unimaginable scale. Nebulae are made of gas, mainly hydrogen, helium, and dust, forming vast clouds that stretch for light years. These clouds are often so dense that the light from stars barely passes through them. In some ways, they're invisible to us, a veil of cosmic mystery that hides the secrets of star formation. But if you look closely, if you know where to look, you'll see the beauty of these nebulae. They glow in shades of red, blue, and purple, as if they're alive, swirling with energy, waiting to birth the next generation of stars. Nebulae are not just clouds in space. They're the beginning of everything. Take the Orion Nebula, for example. It's one of the most famous and well-studied nebulae, and for good reason. It's a stellar nursery where new stars are being born right before our eyes. Within the Orion Nebula, clouds of gas are collapsing under their own gravity, slowly coming together to form new stars. It's in places like this that stars like our sun are formed, out of nothing more than dust and gas. Over millions of years, the pressure and heat in the center of these clouds cause nuclear fusion to begin, and a star is born. This process, slow and steady, creates the very foundation of the universe, bringing new stars to life. And yet, despite all the beauty and wonder of star birth, the nebula is also a graveyard. When stars die, they leave behind a remnant of themselves, a nebula, a cloud of gas and dust that will eventually be recycled into new stars. The cycle of life and death, so natural and yet so cosmic, is at the heart of what makes nebulae so fascinating. But not all nebulae are like the Orion Nebula. Some nebulae are formed by the death of massive stars, which end their lives in spectacular explosions known as supernovae. These explosions are so powerful that they scatter the remains of the star across space, forming a nebula that could be millions of light years across. The Crab Nebula is one such example. It's the remnant of a star that exploded as a supernova in the year 1054, creating a cloud of gas and dust that continues to expand even today. The Crab Nebula is a stellar remnant, a living, expanding cloud of gas and dust that tells the story of a star's violent death. It's a place where new elements are created, where the very building blocks of planets, life, and everything we know are formed. These elements, spread across space by the explosion of the star, will eventually come together to form new stars, new planets, and perhaps, in the distant future, new forms of life. As you drift through space, surrounded by the delicate glow of a nebula, it's hard to fully grasp the scale of it all. These clouds of gas and dust are immense. The Orion Nebula, for example, spans about 24 light years across. That's a distance so vast, it's almost impossible to comprehend. A light year is the distance that light travels in 1 year, about 9.5 trillion kilometers. So when you think about something being 24 light years across, you're talking about an area of space so vast that it's almost beyond measurement. And yet, despite their immense size, nebulae are incredibly fragile, delicate structures. They are held together by gravity, but the force of a supernova explosion or the pressure from a newly formed star can cause them to collapse or expand in ways that alter the structure of the nebula. Nebulae are also incredibly beautiful. When you look at images of them taken by telescopes like the Hubble Space Telescope, you see stunning, vivid colors, reds, blues, and greens, that look almost like a cosmic painting. These colors are not just for show. They represent the different elements that make up the nebula. Hydrogen, the most common element in the universe, gives off a soft red glow, while oxygen can create a blue or green hue. These colors tell us about the composition of the nebula, about the elements that are present and the processes taking place inside. Looking at a nebula through a telescope is like peering into the heart of the universe, seeing the raw materials from which stars and planets are made. It's a glimpse into the future, a snapshot of the beginning of something new. But nebulae are not just beautiful because of the colors they produce. They are beautiful because of the way they exist, fragile, yet powerful, delicate yet full of potential. They're the birthplace of stars, the place where the raw materials of the universe come together to form something new. When a star is born from a nebula, it's like the birth of a new world, a new beginning in the endless cycle of creation and destruction that drives the universe forward. And so, as you lie back and let the rhythm of your breathing carry you into sleep, imagine yourself drifting through one of these cosmic nurseries. You're floating through the swirling clouds of gas and dust, watching as new stars are born, feeling the energy and power of the universe around you. The nebula is alive, filled with the promise of new beginnings. And yet, it's also a reminder of the past, the stars that have come before, the ones that have lived and died, leaving behind the elements that will give birth to the next generation of stars. The nebula is both a cradle and a grave, a symbol of the endless cycle of life and death that shapes the universe. In this moment, as you float through space, you are a part of something much bigger than yourself. You are part of the same cycle that has shaped the stars, the planets, and the life on Earth. The nebula, with all its beauty and mystery, is just one chapter in a much larger story, a story that spans billions of years and stretches across the vastness of the cosmos. And as you drift deeper into sleep, remember that you, too, are made of the same stardust, the same elements that were forged in the hearts of stars and scattered across the universe by the explosions of supernovae. You are connected to the stars, to the nebulae, to the entire universe. And in that connection, there's a sense of peace, of belonging, and of wonder that stretches out beyond the stars and into the infinite night. As you close your eyes, you might begin to imagine yourself floating high above the earth, surrounded by the quiet vastness of space. The noise of the world is far behind you now, and all you hear is the soft hum of the universe. You're no longer confined to the planet's surface. The stars that once seemed so distant are now within your reach. You're gliding through space, and as you look out into the infinite expanse, you notice something incredible. It's not just one star you're looking at anymore. It's millions, billions, even, all clustered together, creating a breathtaking swirl of light and motion. It's a galaxy. The Milky Way is our home, but out there, beyond what we can see with our eyes, there are countless others, each one a world of its own, full of stars, planets, and mysteries. In the universe, galaxies are the giant cities of the cosmos, each one a vast collection of stars, gas, dust, and dark matter. They're the fundamental building blocks of the universe, the places where stars are born, where they live, and where they die. And though we are just one tiny part of the Milky Way galaxy, which contains over 100 billion stars, that's still just one galaxy among billions. The sight of a galaxy, whether it's the Milky Way or a distant one seen through a powerful telescope, is something so magnificent, so vast, that it can be overwhelming. But as you drift deeper into the peaceful expanse of space, you start to understand just how much these galaxies shape the universe. As you float through the stars, you begin to realize that galaxies are not just beautiful, they're alive. The stars inside them are constantly being born, living, and dying. And in that process, galaxies grow, evolve, and change. Some galaxies are small and irregular, while others are massive, containing trillions of stars, their light stretching out across billions of light years. The Andromeda Galaxy, for instance, is one of our closest neighbors, and it's on a slow collision course with the Milky Way. In a few billion years, the two galaxies will merge, creating a new, larger galaxy. Even though that might seem like a far-off event, it's just one example of the way galaxies are constantly shifting and evolving, all in a cosmic dance that's been going on for billions of years. As you float farther into the depths of space, you start to see the true scale of these galaxies. Some are so large that their stars, their gas, their dust, are spread across hundreds of thousands of light years. A light year, you remember, is the distance light travels in 1 year. Nearly 9.5 trillion kilometers. When you consider that a galaxy like the Milky Way is about 100,000 light years across, the size is almost incomprehensible. And yet, these galaxies are not isolated. They are part of even larger structures, clusters of galaxies, or even superclusters, where galaxies group together, bound by gravity, forming structures that can span hundreds of millions of light years. These massive clusters are like the true giants of the universe, pulling each other together, creating enormous gravitational wells that shape the very fabric of space itself. The scale of a galaxy is staggering. When you look up at the night sky from Earth, you're seeing just a tiny fraction of what's out there. All those stars, all those distant lights, are part of the Milky Way galaxy. But even with the vast number of stars in our own galaxy, we're just one small point in the greater cosmic web. The galaxies themselves are far from stationary. They spin, they collide, they grow. The Milky Way, for instance, is rotating, and as it does, it drags along everything within its gravitational pull. It's like a giant whirlpool, pulling stars and planets into its rotation, shaping the structure of the galaxy over time. But galaxies don't just rotate. They interact with each other, merging, colliding, and influencing one another in ways that change the shape of the entire universe. As you drift through the stars, looking at the vast, glowing swirls of galaxies around you, you begin to realize that what seems like a collection of dots in the sky is actually a dynamic, living structure. The stars inside a galaxy are not just sitting there, frozen in place. They're moving, orbiting, being born and dying in a cycle that has continued for billions of years. Some stars are nearing the end of their lives, growing into red giants or exploding in supernovae, scattering their elements across the galaxy, creating the building blocks for new stars and planets. Some galaxies are still in the process of forming, with clouds of gas collapsing to create new stars. And in the vast, distant future, these galaxies will continue to evolve, their stars being born, living, and eventually dying in an endless cycle that has no end. But galaxies don't just shape themselves. They also shape the universe. The gravity of a galaxy is so strong that it can pull on the surrounding space-time itself, bending the very fabric of the universe. This gravitational pull can influence the motion of entire galaxies and even affect the way light travels through space. The result is something known as gravitational lensing, where the light from a distant galaxy is bent around another galaxy, creating a distorted image. It's as if the very space between the galaxies is being warped, bent by the immense power of gravity. And this effect is not just a tiny distortion. It can stretch the light from distant galaxies into long, curved arcs, creating some of the most stunning and mysterious images we've ever seen. Even as you float in the stillness of space, surrounded by the beauty of these galaxies, it's hard to ignore the sense of how small Earth seems in comparison. We are part of the Milky Way, one of billions of galaxies, and our galaxy itself is just one small piece of the greater cosmic puzzle. But even as you drift, looking at the vastness of the galaxies around you, you begin to understand that we, too, are a part of something much bigger. We are part of this grand cosmic dance, a small but significant part of the galaxy that is forever changing and evolving. And then, just as you start to feel the weight of the vastness around you, you remember something important. Despite the scale, the billions of stars, the hundreds of billions of galaxies, this universe is not an impersonal, cold place. It's alive with history, with energy, with potential. The stars, the galaxies, all the elements swirling in the void, they're part of a much larger story, one that we are a part of, one that we are still discovering. And as you float through the stars, you begin to realize that we're not just insignificant specks in a vast universe. We are part of the very fabric of it all, shaped by the same forces, born of the same stars, made of the same dust. The galaxies, in all their magnificence, remind us that even in the vastness of space, there is connection. Each galaxy, each star, each planet plays a role in the greater cosmic story. And just as the stars have been born and will one day die, so too will the galaxies continue to evolve, merge, and change. The universe is not static. It's a place of constant motion, constant growth, and constant renewal. And as you lie there, drifting into sleep, surrounded by the quiet of space, remember that the galaxies are not just distant lights in the sky. They are the very structure of the universe, the living, breathing backbone of everything we know and everything we have yet to discover. As you continue to drift, floating farther out into the universe, you begin to notice that things are shifting around you. The individual stars that once seemed so distant and isolated are now slowly gathering, clustering together in groups. These clusters of stars aren't random, but are drawn together by the invisible pull of gravity, creating vast structures that span across the cosmos. They are like cities of stars, each one bustling with energy and motion, all bound together by the same force that holds galaxies together. You can almost feel the gravitational pull between them, a force that keeps them in orbit, spinning around each other in a delicate cosmic dance. And as you float through these star clusters, you realize just how vast the universe really is. In a universe, galaxies don't just exist on their own. They group together, forming clusters, enormous collections of galaxies bound by gravity. These clusters are some of the largest structures in the universe, and they are home to hundreds or even thousands of galaxies, all held together in a kind of cosmic web. The Milky Way itself is part of a larger cluster called the Local Group, a collection of more than 50 galaxies, including Andromeda, the closest large galaxy to us. As you float among these galaxies, you start to feel the scale of it all. The distance between the galaxies seems so vast, but at the same time, you can sense the subtle gravitational connections between them, the way they tug at each other, slowly pulling each other closer. As you move deeper into space, you begin to realize that these clusters of galaxies are not isolated, but are themselves part of even larger structures. These structures, known as superclusters, are the largest known structures in the universe. They are vast regions of space that contain dozens or even hundreds of galaxy clusters, all bound together by the same force of gravity. Superclusters are like the scaffolding of the universe, the massive frameworks that give shape to the cosmos. Some superclusters are so large that they span hundreds of millions of light years. Their galaxies spread out across the vast expanse of space like an intricate, interconnected web. You are now floating in one of these superclusters, where galaxies aren't just individual stars and planets, but entire systems, entire cities, bound together by gravity in a beautiful cosmic harmony. And yet, even in this immense expanse, you start to see something extraordinary. It's not just the size that's impressive, but the way these clusters and superclusters seem to move together, as though they are part of something greater. You realize that the universe is not static, that it is constantly in motion, that even the largest structures are moving, interacting, evolving. The galaxies in a cluster are slowly drifting toward each other, drawn together by the force of gravity, and eventually, they will collide. When galaxies collide, it's not like the way things crash together on Earth. The stars inside the galaxies are so far apart that they don't collide directly, but the gas and dust inside them are compressed, triggering the birth of new stars. These collisions, although slow and often spread over millions or even billions of years, are the forces that shape the universe. They're the moments when new stars are born, when galaxies merge to create even larger structures. It's a reminder that even in the vast emptiness of space, there's constant change, constant motion. The universe is never still. As you continue to float, you can feel the weight of all this movement, the massive scale of the superclusters, the galaxies, the stars. The gravity of these massive structures warps the very fabric of space-time, bending light and creating effects that are hard to imagine. This bending of light, called gravitational lensing, happens because the mass of the galaxy or supercluster is so immense that it bends the light that passes through it. When you look at a galaxy cluster through a telescope, you might see distant galaxies that have been stretched or distorted by the gravitational pull of the supercluster. It's like looking through a cosmic magnifying glass, where the very fabric of space is warped and twisted by the gravity of these massive objects. It's one of the most mysterious and beautiful effects in the universe. A reminder that the universe is not just full of stars, but full of forces we are still learning to understand. As you drift deeper into the heart of a supercluster, the galaxies around you seem to grow closer, their shapes more defined. The distance between them is still vast, but you can see how they're all connected, all part of a larger structure, each one moving through space in a way that is almost choreographed, as though the whole supercluster is in perfect harmony. Some galaxies are actively merging, others are still on their way toward each other, while some have already merged, forming giant elliptical galaxies. The supercluster itself, though, is slowly expanding, stretching farther and farther out into the universe. The galaxies are bound by gravity, but they are also being pushed apart by the expansion of the universe itself, a force that's been stretching space since the Big Bang. You start to realize that, in a way, everything is connected. The stars, the galaxies, the superclusters, they're all part of this larger cosmic network, a web of energy, matter, and gravity that stretches across the universe. The gravitational pull between these objects shapes everything from the formation of stars to the movement of entire galaxies. And as you float here, among the galaxies and superclusters, you start to understand that everything in the universe, no matter how small or large, is part of this incredible cosmic dance. Every star, every galaxy, every supercluster is bound together by gravity, moving together through space, changing and evolving as time passes. It's hard to imagine, isn't it? The scale of it all. The galaxies and superclusters moving through the vast expanse of space, each one affecting the others in ways we can't always see. But it's happening all the time. The universe is alive with motion, with energy, with life. And just as you begin to sense the immense scale of it all, you feel a sense of calm wash over you. You are part of it too. You are connected to everything. The stars, the galaxies, the superclusters. Every moment, every breath, every thought is part of the same cosmic dance that has been unfolding for billions of years. The universe may seem vast, but you are a part of it, as much as anything else. And as you settle into the peaceful silence of space, you realize that, in a way, it's all just one great, never-ending story. The galaxies, the superclusters, the stars, they're all pieces of a greater whole. A whole that is constantly evolving, constantly changing, and yet always the same. The universe, with all its vastness and complexity, is an endless journey, a journey that continues with every passing second, every breath you take. And as you fall deeper into sleep, you can feel the rhythm of it, the pulse of the universe, slow and steady, like a heartbeat that has been going on for eternity. As you drift off into the calm of the night, your body sinking deeper into the softness of sleep, imagine for a moment that you are floating out in space, far beyond Earth, beyond the stars. All around you is the vast, empty space, dotted here and there with the glow of distant galaxies, stars, and nebulae. The stillness of space is overwhelming, and yet, as you look around, you sense something subtle, something present but unseen, shaping everything around you. It's not something you can touch, hear, or see in the usual way. It's invisible, yet it's everywhere, holding everything in place. And somehow, you know it's there, quietly guiding the entire universe in ways that we're just beginning to understand. This unseen force is known as dark matter. At first glance, space seems empty, doesn't it? The stars, the galaxies, they all appear to float out in the void, disconnected from everything around them. But in reality, space is not as empty as it seems. In fact, the more we study it, the more we realize that most of the universe is made up of something we can't see, something that doesn't emit light, that doesn't interact with us in any way that we can sense. It's called dark matter, and although we can't detect it directly, we know it's there because of the way it affects the things we can see. You might think that if something is invisible, it has no effect on anything. But in space, dark matter is incredibly powerful. It's responsible for holding galaxies together, for keeping them from flying apart, and for influencing how they move. Without dark matter, galaxies would simply scatter, their stars and planets drifting away from each other, unable to stay bound together by gravity. But dark matter doesn't just hold galaxies together. It also plays a role in how galaxies move, how they interact, and even in the formation of the universe itself. It's as if dark matter is the invisible scaffolding that supports the entire cosmic structure, the framework that allows galaxies, stars, and planets to exist and to move in the way they do. You see, when scientists first began studying the universe, they noticed something strange. The galaxies we observed were spinning, but they were spinning too fast. The stars in these galaxies were moving at such high speeds that the gravity from the visible matter, the stars, gas, dust, wasn't enough to keep them from flying apart. There should have been something more, something invisible, something that could provide the extra gravity needed to hold these galaxies together. That's when the idea of dark matter was born. It's not made of the same stuff as ordinary matter, things like the atoms that make up everything we know, but it still has mass, and that mass exerts gravity. So, even though we can't see dark matter, we can feel its effects. It's as if the universe is filled with an invisible web, a network of dark matter that binds everything together. Now, as you float farther through space, surrounded by galaxies and stars, you begin to realize that dark matter isn't just something that exists in one place or another. It's everywhere. In fact, dark matter makes up about 85% of the mass of the universe. That means that most of what we see, stars, planets, even entire galaxies, is just a small fraction of the universe's true mass. The rest of it, the vast majority, is invisible to us, hidden from our sight, but still very much present, shaping everything around us. The most fascinating thing about dark matter is that, even though we've known about it for decades, we still don't know exactly what it is. We can detect its influence, of course, but we've never been able to directly observe it. It doesn't interact with light or radiation in the way that ordinary matter does, which is why it's so elusive. Imagine trying to understand the structure of a room full of objects, but you can't see anything, and the only way you can know something is there is by feeling the way it affects everything around it. That's how scientists study dark matter, by measuring its effects on the things we can see. It's a mystery that keeps scientists guessing, but it's also one of the things that makes space so fascinating. The more we learn about dark matter, the more we realize just how much we still don't know. And yet, despite its invisibility, dark matter is incredibly important. Without it, the universe would look very different. The stars and galaxies we see today would never have formed in the way they have. The universe itself would be far less stable, less structured, and less dynamic. Dark matter is a fundamental part of the cosmic blueprint, shaping everything from the birth of galaxies to the way they evolve over time. In a way, it's the hidden force that holds the universe together that gives it the shape and structure we see. Imagine now, as you float through space, that you can feel the pull of dark matter around you, even though you can't see it. It's like the quiet heartbeat of the universe, the constant, invisible force that makes everything else possible. You don't need to see it to know it's there. The galaxies, the stars, the planets, they all owe their existence to dark matter. It's like the quiet presence that surrounds you, making everything move as it should, keeping the cosmic balance in check. The more you float through space, the more you begin to understand that dark matter is not just an abstract concept. It's something real, something essential to the very fabric of the universe. It may be invisible, but it's powerful, shaping the paths of galaxies and stars, influencing the very structure of space itself. And even though it's something we still don't fully understand, that mystery only adds to the beauty of it. In a way, the unknown is just as fascinating as the known. It's what keeps the universe full of surprises, full of things to discover. As you drift deeper into this vast sea of stars and galaxies, you realize that you are not just a passive observer. You are part of this grand cosmic dance. The same forces that govern the movement of galaxies, the birth and death of stars, are the same forces that shape you, that make you who you are. You, too, are made of the same stardust, the same matter that is scattered throughout the universe. And in this moment, as you relax into the stillness of sleep, you are connected to everything, visible or invisible, known or unknown. You are part of the same cosmic web, held together by the same forces that hold the universe in balance. And with that thought, as you let the gentle rhythm of your breath carry you deeper into sleep, know that you are not just part of the universe. You are the universe, experiencing itself. You are the stars, the galaxies, the dark matter. You are connected to everything in ways that go far beyond what we can see or understand. And that connection, that infinite, invisible bond, is what makes the universe so beautifully complex, so mysteriously alive. In the quiet of space, surrounded by the unknown, you are part of something much greater, and that's a thought that can help you drift off into a peaceful, restful sleep. Imagine for a moment that you're drifting through space, floating effortlessly weightless, with no sound, no time, just the calm stillness of the universe around you. As you look out, you see the stars, each one a distant, glowing point in the vastness. But something starts to happen as you let your mind wander, as you allow yourself to let go of everything you know. The stars begin to stretch, spread apart, until you realize they're not just twinkling dots, but part of something far, far greater. They're part of an entire galaxy, one of billions. And even though each star is so distant, so unreachable, they're connected in ways you can't even begin to understand. You're looking out at the observable universe, at everything that we can see, or that we think we can see, stretching across unimaginable distances. As you float farther out, the galaxies around you start to multiply. They seem to go on forever, like tiny islands in an infinite sea of stars. The Milky Way, where our sun resides, is just one of these countless islands. It's hard to even grasp the scale of it, isn't it? The Milky Way alone is home to more than 100 billion stars. But the more you look, the more galaxies you see, stretching as far as your eyes can take you. And beyond that, even farther still. There are billions of galaxies in the observable universe, each one with its own stars, planets, and mysteries. The numbers are beyond comprehension, and yet, as you float in this space, surrounded by these incredible structures, there's a strange sense of quiet. The vastness is almost peaceful, calming, like floating in an endless ocean of light. As your journey continues, the idea of distance begins to shift in your mind. You're now looking at things so far away, so distant, that the light you're seeing left those galaxies billions of years ago. The light from the farthest objects we can see, traveling at the speed of light, has taken more than 13 billion years to reach us. That means we're not just looking at galaxies as they are now. We're looking at them as they were in a time so far in the past that it's almost unimaginable. The universe, in a way, is like a time machine. When we look up at the stars, we're not just looking at the present moment, we're looking at history. The light that travels across the universe tells us stories from billions of years ago, showing us what the universe looked like when it was just a baby, barely a fraction of its current age. The farther you drift, the more the enormity of it all begins to sink in. The observable universe is not just a collection of stars and galaxies. It's a sprawling, living entity. And though we can only see a small part of it, what we can observe tells us a story that stretches back to the very beginning of time itself. The universe began with the Big Bang, an explosion that happened more than 13 billion years ago. Since then, the universe has been expanding, and everything we see today is the result of that explosion. The stars, the galaxies, even the atoms that make up our bodies. We are, in a very real way, part of the universe, made from the same elements, formed by the same forces, existing in the same space. As you float farther still, you realize that the universe isn't just expanding outward, but also stretching in ways that are still mysterious. Space itself is growing, the distances between galaxies are increasing, and, as far as we can tell, this expansion is speeding up. This strange and incredible fact has led scientists to suggest the existence of dark energy, an unknown force that seems to be pushing everything apart. The more we look, the more we realize that the universe is not static. It's changing, evolving, growing, and we are watching it happen. Even though everything feels still and calm as you drift through space, the universe itself is in constant motion. There is nothing static about it. It's alive, constantly shifting, growing, expanding in ways that defy our understanding. The observable universe is so vast that, even as you float through it, you begin to feel its enormity pressing in on you. The stars, the galaxies, the nebulae, They all seem so distant, so unreachable. Yet, there's an undeniable sense of connection, of being a part of something greater. Everything we see, everything we know, is part of this immense and beautiful universe. A universe so large it's hard to fathom. You are here in this small moment, but you're also part of something that stretches across the entire universe, reaching back to the very beginning and forward to the farthest edges we can imagine. Even as you feel the vastness of the universe surrounding you, you also begin to understand just how much of it is hidden from our view. The observable universe is only the part of the universe that we can see with our current technology, but we know there's so much more out there beyond the limits of what we can observe. There are galaxies that are too far away for their light to have reached us yet. There are regions of space that are beyond our current reach, beyond the edge of the observable universe. The true size of the universe is still a mystery. We can only see what we can see, but what we know is that it's more than we can ever truly comprehend. It stretches beyond anything we can imagine, its boundaries constantly shifting and growing. As you continue to float, surrounded by this incredible sea of galaxies, stars, and light, you begin to realize something important. You are part of this universe. The very atoms that make up your body were forged in the hearts of stars, in the explosions of supernovae, in the processes that have shaped the universe for billions of years. You, in this moment, are connected to the stars, to the galaxies, to the entire cosmos. The universe is vast and mysterious, but it is also beautiful, full of life, full of energy, and full of potential. And though you are small, in the grand scheme of things, you are no less important than the stars you see. You are made of the same stardust, part of the same cosmic web that connects everything, from the smallest particle to the largest galaxy. So as you settle into the peaceful stillness of sleep, with the vastness of the universe stretching out before you, know that you are not alone. You are part of this endless journey, part of the universe itself, moving through time and space, just like the stars and galaxies around you. The universe is vast, yes, but it's also beautiful, mysterious, and full of wonder. And as you drift off to sleep, imagine yourself floating through it all, connected to everything that has come before and everything that will come after. You are part of the universe, and it is part of you, now and forever. The stars continue to twinkle softly around you as you drift deeper, your body sinking into the softness of your bed, your mind gently easing into the quiet rhythm of the universe. You're still floating through space, weightless, yet it's as though the vastness of it all is slowly starting to fade. The pressure of the universe, the enormity, the billions of galaxies and stars starts to soften. You're no longer a tiny speck in a cosmic sea. Instead, there's a sense of peace here, a peaceful embrace, as though the universe itself is gently wrapping you in a blanket of stillness. There is something comforting, isn't there, in the idea that everything around you, the stars, the planets, the galaxies, even the space itself, is part of a never-ending, ever-expanding story. A story that stretches back to the very beginning of time, one that will continue long after we are gone. It's a reminder that, no matter how small we might feel in the face of the vast cosmos, we are part of this beautiful, intricate web of existence. We are made of the same stardust that has formed stars, planets, and life itself. And even though we may seem insignificant, we are an essential part of it all. Now, as you float farther into the peaceful silence, you start to feel the gentle pull of that understanding. It's like a quiet whisper that says, you belong here. You are part of this. The universe, with all its immensity, has a place for you. The stars that have lived and died, the galaxies that have collided and merged, the nebulae that have cradled new stars into being. These are the same forces that created you, that shaped you. And in the quiet depths of space, you begin to realize that the same things that have formed the universe are still working within you. The elements forged in the hearts of ancient stars are what make up your body, your very being. You are part of the stars. You are part of the universe. It's not a scary thought, is it? To know that you are part of something so vast, so ancient, so full of wonder. No, there's comfort in it. It's like being a part of a larger family, a family that spans time and space, whose roots stretch back billions of years, and whose future is still unfolding. The universe is constantly changing, growing, expanding, and so are you. As the stars are born, live, and die, so too do we experience our own cycles of growth and change, of living and learning. But just like the stars that are born in nebulae and explode in supernovae to create new stars, everything we are and everything we know is part of a cycle that is far greater than any one of us. We are connected to something much larger than ourselves, and in that connection, we find peace. Now, as you feel yourself growing lighter, drifting closer and closer to sleep, the vastness of the universe doesn't seem so overwhelming. It feels more like a warm embrace, a reminder that everything is part of a greater whole. The stars continue to burn, the galaxies continue to spin, the dark matter continues its silent dance, and all of it, every single piece of it, is interconnected just like the beat of your own heart. You are part of that rhythm, part of the pulse of the cosmos. And as you rest here, you're not alone. You are part of the same story that began billions of years ago, a story that continues to unfold in every breath you take, every dream you have. The quiet hum of the universe surrounds you, and you can feel yourself becoming lighter, as though you are merging with the space around you. The stars seem to blink slowly in the distance, their lights stretching across the universe, carrying with it the whispers of time. The galaxies continue their slow, graceful dance, colliding and merging, giving birth to new stars, new worlds, new possibilities. You are part of that dance. You are part of the endless cycle of creation and transformation that has been unfolding since the beginning of time. And just like the stars, you, too, are constantly evolving, growing, and changing. But even in this constant motion, there is stillness. In the quiet of space, in the calm of the night, you can sense that everything is as it should be. There's a gentle balance to it all, a rhythm that holds everything together. The universe moves, yes, but it moves with purpose, with intention. And so do you. You are part of that purpose, part of that intention. In the vastness of space, in the immensity of the universe, you are not a small, insignificant being. No, you're a part of it all, woven into the very fabric of existence, shaped by the same forces that shape the stars, the galaxies, the nebulae. You belong here. And now, as you begin to feel the pull of sleep, the gentle rhythm of the universe wrapping you in its arms, you can let go. Let go of the weight of the day, of the worries, the thoughts, the distractions. You are safe here in the quiet embrace of the cosmos. Everything is in its place. Everything is moving as it should, and you are part of that movement. There's no need to rush, no need to worry. Just let go and let the universe carry you into the peaceful, restful sleep that you deserve. Feel the quiet of space around you, the endless stretch of time and distance, and know that you are part of it all. You are connected to the stars, to the galaxies, to the very heartbeat of the universe. You are part of a story that is vast, ancient, and beautiful. And in that story, you're never alone. As you drift deeper into sleep, let the gentle pull of the cosmos lull you into rest. The universe is vast, but it is also calm, full of peace, and full of wonder. And you, as a part of it, are part of something beautiful, something infinitely precious. Feel the peace of that. Feel the comfort of that as you slip into the soft embrace of sleep.